Namaskar. Let's see what are the selection criteria that we should follow while selecting a microcontroller. Alright. So basically we have to understand on what basis we should select a particular microcontroller for our application. Right? So first of all, we have to understand that which companies that we will be looking. So the general companies for microcontrollers are Texas Instruments, Microchip, Renesas, then ST Microelectronics, Analog Devices, and Infineon are there, right? More are there, but I am counting some of the best ones. If you go ahead with low cost and like a sturdy ones, so this is the best one. Okay, if you want to go ahead with very high cost or something, Analog Devices would be the one. Even Infineon is little bit higher cost. Microchip Pick series is very good ones. Okay, Renesas RL78 series are there. ST Microelectronics is very popular for STM series, STM32 series and all. Okay. But before considering the manufacturers, what we have to understand that what is my application. Okay, whether it is a consumer application or industrial application or a space grade or automotive grade, or what kind of the application it is. Okay, next would be uh, based on the application, like whether it is a handheld application or like power supply will be there. Okay, so handheld you need to have very ultra low power. So many microcontrollers you will see that one of them will be like simple series, another one will be very ultra low power. So ultra low power goes with handheld devices. Okay, next you have to decide how many number of GPIOs that you need, like what are the functionalities that you will be having. Maybe you need like just 20 pin microcontroller, that is enough for your application, and sometimes you need even 100 pins microcontroller, as high as let's say 144 pin or maybe 208 pin. You can go ahead with 256 pins. So as the application size increases, the microcontroller size also, or the package size also increases. Okay, so that we'll talk about based on the number of GPIOs and speed of microcontroller. Okay, the frequency of operation that you need, let's say 4 megahertz or 40 megahertz or 400 megahertz. It can go like as high as possible. Okay, so 420, 32, 80 megahertz, 100 megahertz, 180 megahertz, 200 megahertz, right? So basically we have to understand what kind of application that we are using. Suppose you want to use a microcontroller in like your fan, basically like ceiling fan. So there you don't need very high frequency. I mean 4 megahertz will be enough. Okay, or 16 megahertz will be enough. So even if you go ahead with a 16 megahertz top speed of microcontroller, this will be more than enough. We will be working not more than like 2 megahertz or 4 megahertz frequencies. Then number of bits. So basically these days everyone is like preferring 32 bits because it has become very general now, and lot of resources are available with 32 bits only, because now 8 bit and 16 bits are being little bit less popular, but still they are preferred for very low end applications where you have to have a price like crunch, and where you have to have the price constants basically. If the application is very low end, then you can go ahead with even 8 bit, but I'll recommend you go ahead with 32 bits because you will be having a lot of supports and resources available very easily. Coming to the fact of like communication interfaces. So what kind of communication interfaces that is available with the microcontroller that you can see. At the same time, based on your application need, you will be having this decision. So definitely you may need some UARTs, okay, and SPI. So UART, like UART to USB communication, you can go ahead, okay, or board to board communication. If you need, UART will be necessary. Serial to peripheral communication, if it is needed, like you have to interface some ADCs or DAC or some IO expanders, or any kind of like EEPROMs also comes with SPI interfaces. Even I2C are very popular with low speed like connections. So I2C, or like it is also called as inter-integrated communication. Okay, inter-integrated circuit communication. Then CAN and LEAN, okay, controller radial network, on all those things. If you have to have very high-end applications, there you may need to have USB and Ethernets as well. Okay, so if you need, based on these criteria, once you decide this, you have to write it down, all these design constraints. Then only you will be able to find out a particular microcontroller for your application. Coming to the fact that memories, how much memory you need, whether you need flash memory, let's say 32 kb you need, or 64 kb you need, or 128 kb you need, or 256 kb you need. So flash memory is nothing but the program memory, like you will be writing a code which will be residing in the microcontroller, like forever. Okay, and that will be the program that will be running continuously. So that is called flash memory. SRAM is, like a static random access memory. So this will be basically, like a little bit lower size. So that can be around, sometimes 1 kb, or let's say 2 kb or 4 kb, or even it can go up to 16 kb or 32 kb for high end, like SRAMs. EEPROM, if it is available, it is fine. You need to have, then you have to decide about it. Otherwise, you have to put a separate EEPROM, let's say 1 kilobit or 2 kilobit, or maybe like 4 kilobits around, for your live data captures. Okay, and that can be communicated through I2C communication very easily, or even serial microwire communications. Now, if you need to have LCD in your application, so for LCD, you need to have LCD controller as well. So that you have to decide, or otherwise you have to use a separate LCD driver for that. So if it is, integrated into the microcontroller, it is very easy to go ahead with LCD integrated. DMA channels and all those things. At the same time, existing MCU in your company, that is the best thing that you have to have look. Okay, you can discard all these application things, and you can always see if there is an existing microcontroller that the company's organization is already using for the same application. You can directly go ahead with that microcontroller. And at the same time, if that MCU is on the verge of, like end of life, or not recommended for new design, still that is best, because what you can do is you can take that microcontroller as a reference and search against that. Okay, so it is very easy to find a microcontroller having the parameter of existing microcontrollers. Okay, so this will give you a reference, very easy to find your different microcontroller. Okay, now, do you need some ADC channels? Like you want to use integrated ADCs of the microcontroller DACs. If you have to apply, like apply some DAC output, timer, how many you need, or PWM if you have to run some uh, like I mean high half bridge or full bridge or something like that, or motor controller and all. There you may need PWMs. RTC and watchdog timers are generally available in all the microcontrollers. Okay. Next, if we go ahead, what is the power supply that will be required? Like your power of working is around, let's say 3.3 volt general, but sometimes it goes up around, like 1.62 volt to 5.5 volt. Okay, so there you can see it can work up to 1.8 volt also, 2.5 volt also, 3.3 volt also, and 5 volt also, right? So for very sturdy application, rugged application, generally people still are going with 5 volt applications. Okay, but I will recommend you, like, go ahead with 3v3 application, 3v3 voltage supply for your applications. What are the power modes that is there available? Like whether it is in sleep mode or deep sleep mode or power down mode. Why it is recommended is, like, suppose you have a handheld device. Okay, so there you have a very, like, high constraints on power supply decay. So there the microcontroller, if it goes to sleep mode or deep sleep mode, there the power consumption will be very, very less. Okay, so in that case, your like battery life will be higher. So if these modes are available in the microcontroller, it is very good. Okay, what is power on reset criteria? Like whether you need to press the switch, or it can be resetted through your programming method or something like that. I already mentioned about frequency of operation. Next, these days almost all microcontrollers are coming with external crystal for clock generation, so that you don't have to worry about, like internal crystal will be always there. But if you need to have a very high accurate, like accuracy I cannot compare now because almost all the microcontrollers are coming with very high accuracy crystals. But still, if you need to run with external crystal, then if it supports or not, that you have to look into. Almost all the high-end microcontrollers are supporting. Low end there may be a possibility of not having external crystal supports. Okay, coming to the fact that external memory controller, like you can interface your SRAMs or ROM or SD-RAMs, or like DDRs. So DDR memory interface, or SRAMs memory flash, all these things can be still supported by the microcontroller for memory integration, because you may have to have a requirement of very high amount of code size, and in that case you need to have external memory controller supports, right? Then if the microcontroller is having operational amplifier, this is these days almost all the microcontrollers are including one or two amplifiers, because that ADC may need to have like some buffers, and instead of using a separate op amp for that, to make it the low cost applications, they are trying to utilize inbuilt general purpose amplifiers. Okay, so instead of using separate buffers or separate amplifiers as a buffer for ADC applications, they are trying to use operational amplifier which is built in the microcontrollers. Okay. Now, before going to the package, what is the number of pins, total pins that you need to have, and what is the lifetime? That is very important. Okay, like suppose you are going to have a go for a new design. Okay, then at least any microcontroller that you are choosing, you must connect to the manufacturer or vendors who will give you exact idea of the microcontroller lifetime. So it must be around 10 years, or I mean more than that. Then only you go ahead with new design. I have shown you here some of the package size that is available, and very frequently people utilize. So generally, if you have to have a low cost and a low end application, people go ahead with SOIC or SSOP package. SSOP package, okay. Even TSSOP package are preferred because they are very easy to handle. The pins are outside, it is accessible, and it is easy. Okay, and you can go ahead with QFN package also, which will be little inside, and LQFP package for bit higher pin count. So TSSOP and SSOP pin counts are up to around max 48 pins you will see, not more than that. So like 16 pin, 20 pin, 24 pin, or 28 pin. So I will tell you the number of pins that is available with SOIC and TSSOP. That is coming up as, let's say, 16 pin, 20 pin, 28 pin, 32 pin, and then 44 pin, 48 pin, something like this. Okay. Coming to the fact that QFN package, all it are these are coming like 16 pin, or any other pins are also available. 64 pin, 80 pins, and 100 pins, all these things are available. Okay. LQFP packages are much preferred because they take less space and pins are also accessible outside. Next is ball grid arrays. So they are very high count pins numbers. Okay, so if you need some 200 pins, 208 pin, or like 256 pins, so those things are there with BGA packages. So these are the criteria that is available for the microcontroller selections. Coming to the fact that for programming methods, like how you will be programming the microcontroller. So one of the best technique that is used is JTAG technique. So where you may need around 6 pins of the uh, microcontroller, where you will have TDI, TDO, TCK, and TMS, and one will be your VCC or VDD and ground. So minimum 6 lines will be required. Okay, if you want to go ahead with little bit higher pin counts, then you may need some reset signals or something like that. And that makes it like around 10 pin total or 14 pin. Okay, so standards are, I'll tell you, JTAG. You can create a JTAG, your own JTAG with 6 pins or 10 pins or 14 pins, or the main JTAG that comes from the like direct programming jigs are 20 pins. So these 20 pins are having lot of extra pins and recurring pins. I mean to say duplicate pins. So this 20 pin also can be converted to 6 pins or 10 pins or 15 pin, 14 pin. Okay. These days, all the microcontrollers are coming with SWD programming, where only two wires will be required: SWDIO and SWSCK. Okay, so this serial wire data input output and one clock line, and two more will be required. That will be definite. One will be VDD and another one will be ground. Okay, so only four wire will be enough to program this. There is a programming method directly coming up with by wire, that is only two wire. Okay, swim technology. Okay, so this swim technology is also there. For low end applications, swim or SWD is preferred. For very high end application, definitely JTAG will come up because it is very easy to debug. Even SWD is having debug capability, however JTAG is much easier. All right. So if you list out all these parameters in an Excel sheet and write it down, like what do you need? So based on that criteria or capabilities, you will be able to find out, like any microcontrollers that you need. Let me give you, like a microcontroller example that will be easier for you to understand how we are going to go to website and search for a microcontroller for any application. Okay. So let's go to Google and I'll type it down for you, Texas Instrument. Okay. So I'll search from Texas Instrument first, and then once we come here, what we have to understand is, I'll give you one example, very easy example. So these days, like Texas Instrument has released one series of microcontroller which is called MSP M0. Instead of MSP 430, MSP 430 series, same way they have released MSP M0L and MSP M0Z. So once we click the product series, we have microcontroller and microprocessors. Okay, so once we go ahead here, we have ARM Cortex. So which Cortex do you need, like ARM Cortex M4 or Cortex R MCUs? So these are the things. Okay. So suppose we have decided that we'll go ahead with little lower end, so M0 plus is the lowest in that this guy is having. If you want to have a look on this, you can see the videos of around 2-3 minutes. It is there, and they have told that most comprehensive portfolio of ARM Cortex M plus MCU deliver the sensing and processing features you need. Okay, so if you want to browse by category, you can browse it by category. So you can, I just now told you MSP M0C M0L series with 32 megahertz. Okay, and 64 KB flash. If you want to go ahead with more KB, flash memory, then 128 KB, which is 0G series. Okay. So this will refine your search very easily. Like what is your decided, like flash memory, based on that you can try to search. What is the frequency of operation, based on that you can try to search easily. Okay. So this is entry level, this is advanced microcontroller automotive, this is also entry level in this series, and this is advanced microcontroller. This is having CAN controller for industrial and automotive application, like CAN is also there available in this. Okay, so this is how it is easy to find out where to search. Okay, next coming to the fact that this particular like table so what it is going to give you is the gray, like a little bit gray one is 24 megahertz. So these are 24 megahertz. Okay, next this is 32 megahertz, the little bit greenish one. So this is 32 megahertz series. Okay, and this is like 80 megahertz and 80 megahertz plus CAN, both are there available with yellowish one. Okay, now coming to the fact of flash memory. So flash memory is 8 KB. So if you want to have a very entry level and very low cost, then MSP M0L 1303 you can go ahead. Okay, now one more criteria before selecting this particular microcontroller, what you have to understand is how many pins that you need. So you need to have 8 pin as low as possible and as high as 64 pins, that is available with M0 Cortex. Okay, So M0 plus Cortex only 8 pin to 64 pin. If you want to go ahead with more than 64 pin, then you have to go ahead with another series like M1 or other series where they're like M4 series, right? So let me give you an idea of, like, let's say 32 pin or 20 pin. Let's say 20 pin I want to select VSSOP package, TSSOP and VQFN package. Okay. And our aim is to go ahead with 32 KB. So you can see only this one microcontroller is available. So you click on this. So once we click on this, we can see ARM Cortex M0 Plus microcontrollers. We have only 4 entries. We can see we have MSP M0L1105 and MSP M0L1305, 1305, 1345. Okay, so these are 32 KB flash with 20 pin categories. Okay, and now if you want to reduce the cost, you can see it is $0.39 only, less than half dollar. And if it is a little bit higher cost, like I mean automotive ones, so this will be around $0.6 or $0.576. You can see quickly you can see quickly, like frequency of operation is 32 megahertz max, flash memory is 32, and RAM is 4 KB. We have total number of GPIOs, that is 28. Okay, so number of pins I was searching for 20 pins, but I have I'm taking for 32 pin. Okay, so this is still good. Okay, next is UART. You have two number of UART, and number of I2C is also 2. Here it is 1. So if you go ahead with 1105 that I have been teaching you recently, so you will have only one I2C. There was very big constraints there. So if you want to increase the number of like IOs and I2Cs, then you can go ahead with this one. Okay, both of them are having SPI 1 and this is having only one version of packaging, that is VQFN package of 32 pin count, and this is having 16 pin, 20 pin, 24 pin, 28 pin and 32 pin count. Okay, so but only one thing is, even if you go ahead with the 32 pin, you will still have only one I2C. So that's the problem that you may face. Now coming to the fact that the temperature, like operating temperature range, it is -40 to 105, and this is active. So what I'll do is I'll go ahead with automotive one, which will be used for little bit higher, like applications. But as you can see, this is preview, means it is a very new microcontroller, like it is going to get introduced. So if you want to take a chance and try it with this new one, it is really good. Okay, otherwise this is also good to go ahead, because I was teaching on this only, and this is the one I have found out very useful as well as very easy to go ahead. Okay, all right guys, so once you click there, what you are going to see is a product table for this particular microcontroller, and all the like parameters, description in full detail. Okay, and what are the features that is available, that you can see directly without downloading the data sheet. Okay, so like how many ADCs, how many DACs, and how many DMA channels, and what are the timers, PWM capabilities, and all the parameters that is available with you, that will be available. Okay, so as you can see, I have directly landed up on this particular microcontroller, which I was teaching you from beginning to end. Okay, and this is very very low cost, as low as around 35 rupees just, or 32 rupees just. Okay, so if you want to develop a very low cost application, let's say some fan application, or maybe temperature measuring device, or maybe LED drivers, just you need one or two GPIOs to control them. So for those applications, these are very easy, or maybe energy meters or something like that. So let us open this particular microcontroller datasheet. Once you open, I have already taught you that what are the different features of this particular microcontroller and how to design the microcontroller circuit, that we will see in our next videos. So hope you have understood the fact that how to search for a microcontroller, and what are the criteria that is available, that you need to look into the microcontroller selection criteria, right? So if you do find this video useful, you do like and subscribe for my channel, And at the same time, if you do have any questions regarding the microcontroller selection process, or if you do have any projects that you are like working on and you are looking for a microcontroller that you need suggestions for, I am always there to help that out. I can find you out a microcontroller for you for your applications. Okay, so good. Thank you so much. Bye.